So this video is for the mixed practice for lessons 1 through 3. I'm just doing a few problems from each section, square roots, factoring, solve by graphing. But hopefully it's enough to answer some of your questions. So we'll start with number 2, which is 4 times radical 128. Remember, when you're simplifying square roots, you need to know the list of the first at least 12 perfect squares. So I'll write them here just really quickly. Now from that list, you are looking to break down the square root of 128 by finding the biggest perfect square from that list that goes into 128. So you can take a minute, look using your calculator. The coefficient of 4 is going to stay the same. Now 128 is actually 64 times 2, and 64 is on your list right here. So we're going to rewrite this as radical 64 times radical 2. You know that radical 64 breaks down into 8. So you leave your coefficient of 4. Radical 64 simplifies to 8, and we're going to multiply that by radical 2, which does not break down. The last step here is you have to multiply the coefficients 4 and 8, which is 32, square root of 2. If you wanted to, you could check that answer in your calculator. Now when I look at number 4, I have a square root of negative 50. When I have a negative under the radical, I have to think about the number I, which is the square root of negative 1. So anytime you have a negative under the radical, that's one of the factors you need to pull out. Now the biggest perfect square that goes into 50 is 25. Okay. We're going to rewrite this as radical 25 times radical 2. 25 times 2 is 50. Now to simplify this, we know that radical 2 does not break down. Radical 25 is 5. And the square root of negative 1 is your imaginary number I. So this simplifies to be 5I radical 2. All right, the next section is solve by factoring reviews. We'll just do a couple here as well. Remember, when you solve by factoring, you have to make sure that your quadratic is set equal to 0, which we do have in number 7. Number 7 is a trinomial. We look, there is no GCF, so I go ahead and multiply the leading coefficient by the constant. 1 times negative 24 is negative 24. Because I'm multiplying to be a negative, I need one positive and one negative number. I'm going to start with positive 1 and negative 24, 2 and negative 12, 3 and negative 8, 4 and negative 6. Now I need to switch my positives and negatives to give me my other options. So negative 1, positive 24, and so on. So that is my complete list of factors of negative 24. What I need is to find a pair of those numbers that multiply to negative 24 and add to 2, positive 2. And it looks like my number is going to be negative 4 and positive 6. So what I'm going to do now is I'm going to do the method of split the middle. We bring the first term down and the last term down, set it equal to 0. The middle term of 2 splits up into minus 4x plus 6x. From there, you do the method of grouping. So you put the first 2 terms in a group and the last 2 terms in a group. And from each group, you look for GCF. X squared and negative 4x both have an x in common. So you pull an x out in front, and you'll be left with x minus 4. The next group has a positive 6, so I'm going to divide a positive out. Looks like I'm going to divide out a positive 6 here. So when I divide that out, I get x minus 4. Well, my final factored form, since these are the same, is x minus 4 times x plus 6. Now we're solving this quadratic by factoring, which means that now I need to take each factor and set it equal to 0. Once I solve these are going to give me my solutions. So on the left here, I add 4, and they get that one of my solutions is positive 4. On the right, if I subtract 6, I will have a negative 6 as my other answer. All right, number 8, 4x squared equals negative 3x. Remember, we said above, we have to be set equal to 0, which I don't have here. So I'm going to move the negative 3x to the other side by adding it. That's going to allow that to cancel so that I have 0. All right, so in this problem now I have 4x squared plus 3x equals 0. I only have two terms, so the first thing I do is look for greatest common factor, which I do have. I'm able to divide an x out of both terms. When I divide an x out in front, inside I'm left with 4x plus 3. Now I'm factored, I just need to solve. So I take each factor that has an x and set it equal to 0. The first one's easy. I don't have to solve it. I just know I have one root at 0. The other one here, I'm going to subtract 3 first, and then divide by 4. So your other x-intercept is at negative 3 over 4, which is negative 7.5. All right, so that should help you with a couple of the factoring ones. And then on the back, we're going to review graphing. I'm going to pull up Desmos here. All right, in order to graph this last quadratic here, which I believe is the last one, yep, we're going to graph this on the grid, and then we're going to find the roots and decide if this quadratic is able to be factored. So we're going to go to Desmos and type x squared minus 4x minus 12 in. So let's see here. We'll have x squared minus 4x minus 12. There's your parabola. So the first thing we need to do is we need to graph this on our grid. We have a grid there to graph. So we click the gear and we click the table. And it looks like I should be able to plot, looks like maybe from negative 2, which is where we start. And I should plot a few more points than 2. So maybe I need to add 3 to my table, 4, 5. That looks like I have a point there at 5. Let's see what 6 gives me. 0. Yeah, I can plot all those points. So we're going to plot that entire table from negative 2 to 6. So I want you to pause the video. I want you to use the table to help you plot the points. All right, and there's my parabola. You should have the same parabola on your graph. Now, from Desmos or your graph here, you should be able to find the roots. Those are the x-intercepts. And it says here that your roots are at negative 2 and 6, which you should be able to see on your picture here. Negative 2 and 6. So we'll write that on our line here. And those two numbers are rational numbers. And rational numbers, when you have those as roots, means that yes, if I wanted to, I could factor this quadratic. All right, try the other problems on this practice. If you have questions or concerns, ask your teacher for help or check the key.